What if we threw liquid nitrogen into the sun? Liquid nitrogen is simply nitrogen, a common gas in the air, that has been cooled until it's extremely cold, around -196 degrees Celsius. At this temperature, it turns from gas into liquid, similar to how water turns into ice, but at a much lower temperature. If you put something into liquid nitrogen, it freezes almost instantly. For example, if you dip a flower or a piece of fruit, they would become so cold that they'd turn brittle, like glass, and could be easily crushed. When liquid nitrogen is exposed to air, it quickly turns back into gas, causing it to evaporate and release cold vapor, creating that mist or smoke effect that many people find cool. It looks like water because it's a clear liquid, but it's so cold it can cause frostbite if it touches your skin, freezing it quickly. If we threw liquid nitrogen into the sun, the impact would be insignificant due to the vast differences in scale. The sun is a blazing sphere of plasma, with temperatures at its core reaching 15 million degrees Celsius, and its surface around 5,500 degrees Celsius. Liquid nitrogen has a temperature of -196 degrees Celsius, which seems incredibly cold by our standards. But compared to the sun, it would be irrelevant. But let's imagine a scenario where throwing a huge amount of liquid nitrogen into the sun caused a dramatic effect. We could create a situation where this cold material interacted with the star in a catastrophic way, resulting in a series of surprising reactions. By dumping a colossal amount of liquid nitrogen directly into the sun, the interaction between the ultra-cold material and the superheated plasma could cause a kind of cosmic thermal shock. In this hypothetical scenario, the sudden cooling of a significant portion of the sun's surface could trigger a chain reaction of instability. Here are the dramatic effects we might imagine. Colossal plasma eruptions. Upon hitting the sun's surface, the liquid nitrogen could fictionally create an extreme cooling zone. This would cause the solar plasma in adjacent regions to rapidly compress, triggering massive solar flares. These solar flares could be thousands of times more intense than what we normally see, releasing an immense amount of radiation and charged particles into space. Apocalyptic solar storms. With these plasma eruptions, enormous solar storms could be launched toward the planets in the solar system. Earth, for instance, could face geomagnetic storms so powerful that satellites, power grids, and communication systems would collapse globally. Spectacular auroras might be seen all over the planet, but at the cost of technological devastation. Unstable solar fluctuations. The shock between the liquid nitrogen and the solar plasma could trigger instability in the sun's thermal balance, causing its surface to oscillate between cooling and overheating. These fluctuations could alter the sun's brightness, making it shine brighter at times and dimmer at others. For the planets, this would result in unpredictable climates, from intense heat to dramatic cooling. Alterations in nuclear fusion. In an even more exaggerated scenario, we might imagine that the contact between nitrogen and plasma could disrupt the nuclear fusion processes inside the sun. While unlikely in a real scenario, in this fictional view, fusion could be briefly interrupted in certain areas, creating giant sunspots and spreading cold regions across the sun's surface. These large-scale spots could temporarily reduce the amount of energy the sun emits, causing a significant drop in Earth's temperature. Premature supernova effect. In an extremely imaginative scenario, this immense amount of liquid nitrogen could alter the sun's structure so dramatically that it would enter a state of collapse. This collapse would lead to the compression of its core, generating a gigantic explosion known as a premature supernova. This would be the end of the solar system, as the resulting explosion would vaporize nearby planets and release colossal amounts of radiation. Imagining what would happen if we threw liquid nitrogen into the sun is a fascinating exercise that makes us think about extreme interactions between elements under unusual conditions. Liquid nitrogen, with its incredibly low temperature of -196 degrees Celsius, seems like a substance that could cause a dramatic reaction when in contact with something as hot as the sun. However, scientific reality tells us that, due to the sun's colossal scale and unparalleled energy, any effect caused by liquid nitrogen would be tiny and practically unnoticeable. Still, exploring this idea opens the door to thinking about the limits of physics and imagination. In a fictional scenario where these elements reacted in extraordinary ways, we could imagine a series of catastrophic events. The contact between liquid nitrogen and the sun's surface could generate colossal plasma explosions, creating solar flares much more intense than usual. These solar eruptions could send extremely powerful geomagnetic storms throughout the solar system, potentially causing havoc to satellites and communication systems on Earth. While this possibility is unlikely, it highlights the sun's power and how small variations in its activity can have devastating impacts on the planets around it. Furthermore, we might imagine thermal instability in the sun caused by this hypothetical interaction. Liquid nitrogen could, in an exaggerated scenario, create temporary cooling zones, leading to fluctuations in the sun's surface. These fluctuations could alter the sun's brightness, generating periods of abnormal heating or cooling on Earth and other planets, creating unpredictable climate chaos. This leads us to reflect on how even small variations in solar activity can affect life and climate on our planet in profound ways. And so, we come to the end of this imaginative journey. It may seem like a crazy idea, but it makes us think about the power of our star and how small we are in the vastness of the universe. Even though science shows that something like this would have an insignificant impact, exploring these possibilities helps us better understand how cosmic forces work. If you enjoyed this scientific trip and want to see more thought experiments and space curiosities, don't forget to like the video and subscribe to the channel. Here at Sir Outermost, we're always exploring the fascinating and the unknown of the universe. Leave a comment with your thoughts or suggest new topics for us to explore together. See you in the next video, and remember, the universe is vast and full of mysteries waiting to be uncovered. Until next time.